This Math 30-1 review lesson is on solving log equations. There are two main types that you need to be on the lookout. The first one is when there's logs everywhere. If there's logs everywhere, you're going to use the laws of logs to simplify until you get to a single log on both sides. Once they are the same log on both sides, then you can equate the logs. Drop the logs, so to say. Then you need to make sure that you verify your solutions because all of the arguments cannot be a negative number. So just make sure you check for extraneous roots. Type number 2 is when you've got a non-log term present. So that means that there's a constant term or a variable, something that doesn't have a log in it. So if that's the case, you're still going to use your laws of logs, but you're going to simplify it to the form log base b of something equals a number. Then once you've done that, you can convert it to your exponential equation and solve that equation. So just a reminder to check all of your answers. The questions will never tell you to check it. That is your responsibility to check for extraneous roots and also just check your answer in general. So the first question here asks us to solve algebraically. You can solve it using your graphic calculator to check your answers, but that would not be an appropriate solution for solving this question. You would actually get 0 marks even if you found out the correct answer. So to solve this, I'm going to try and figure out which one am I trying to do. So this one here is a constant term with the 2. Right, I've got this 2 without a logarithm, so that's going to tell me to use type 2. I could try to rewrite that log 2 as a logarithm, right? Log 4 of, let me think that one through. Okay, so log base 4 of 16 would equal 2, so I could replace that and totally solve that one this way. But let's just assume that we weren't able to do that. So we're going to use laws of logs to simplify. So negative x is going to be multiplied x equals 2. And now that I have it as a single logarithm, I'm going to convert it. Remember, my g kicks the 4 over to the other side, which pushes up the 2. And on the left-hand side, I'm left with negative, oh, let me rewrite that there, negative 6x. Okay, so 4 squared, that's 16. I'm going to rewrite my quadratic in descending order. X squared minus 6x minus 16 equals 0. Now I have a quadratic that I need to factor, so I look for my magic numbers, which means that I'm going to add to negative 6 or multiply to negative 16. So the two numbers that do that are negative 8 and 2. I rewrite my middle term using negative 8 and positive 2. Okay, 2x minus 16 equals 0. And then I do factor by grouping. X factors out, I'm left with 8, x minus 8. And then here we're going to factor out 2. And we're left behind with x minus 8. So I want those two binomials to mesh up because then I can factor them out. Again, it's like double factoring. X minus 8 and then left behind with x plus 2 equals 0. So now we can set both of those equal to 0. I get x minus 8 equals 0 and x plus 2 equals 0. Reminder, if you want to use the quadratic formula here, by all means, just make sure that you show all of your steps. Okay, so I have two solutions. I need to check to see if either of these are extraneous. So if I put 8 into that first logarithm that we started with, I would have negative 8 as my argument. So that tells us here that that is an extraneous solution. And that my only solution is going to be x equals negative 2, which gives us a positive exponent, or a positive argument, and also is a solution that satisfies the equation. Okay, let's try the next one. This one is also asking us to solve algebraically. However, now I've got logarithms for every single term. I don't have a constant. So if I'm going to solve this one, I will still start with my laws of logs. And multiplying here. And then once I get it down to a single logarithm, it means that the arguments must be equal to each other. So it means that x times x minus 3 must be equal to 10. So let's set that up. We've got x squared minus 3x on the left-hand side equals 10. Now we have a quadratic equation. So I am going to move the 10 over, and then once again, just like the previous page, do decomposition. So two numbers that add to -3 and multiply to -10 are -5 and 2. So I have x minus 5 multiplied by 2 equals 0. Equals 5, x equals -2. So if I put a -2 in for the first logarithm, that will give me a negative argument. So that is not a solution, it's extraneous. The only solution is x equals 5.